Welcome back to Element 14 Presents. I'm Lorraine, and this week we're going to make a Fort VOX voice box. So Fort VOX is kind of a play on Fort Knox, and a voice box is a box that's locked with a voice password. In my day job, I work at Lancaster University in the School of Computing and Communications, but it's the people from our linguistics department that have gotten in touch. They want to build a voice box, a box that has something locked inside it, like a treat, and it's locked with a password, but it's a voice password. So it's something like my voice saying, my voice is my password. And they want to see how children at like outreach events will try and break into this box. Some of the stuff we'll need for the project then is a box, a speaker so we can hear the voice password, a microphone so we can listen to people's attempt at breaking the voice password. They want to add a screen to show the children how close they are to breaking that percentage, that password, by showing them the percentage. And then a way of opening the box. So maybe like a servo or something that will like open the lock or open a section of the box, and a button to kind of start things going. Let me draw that out. So the box then, I'm not very good at drawing boxes. Let's just draw a square. Oh, no, we're drawing a cube. Oh, that's not bad. So inside we have our computer and probably going to be a Raspberry Pi. So let's list the kind of stuff that we need. So we need a mic, a speaker, what did I say? A screen, a button, a servo to spin open the lock or the door. I think that's it. So in here will be our device with all those things attached. So we're probably looking for a hat that will do these with some extra pins for these three. So we need to kind of go shopping, look what kind of hats we can get for the Pi that will do all of that. Probably won't get mic and speaker together, so maybe it's going to be like a little tiny speaker that we can attach to things, which should be fine. This is not very good scale. I don't want a massive box. And then we can build like a layer, a shelf in the box. And they've said they want this to be transparent. I don't know how I'm going to draw that shelf. That doesn't look very good. But you can see the Pi, right? They don't want it to be like a mystery to the kids. They want to teach them about technology. So you can see the Pi. So all this will be like a see-through box. And then on the top, there will be this shelf with the prize. So they can also see the prize. So it's going to be a voucher or a piece of chocolate. So I'm thinking in the lid, we have like this circular hole. And then, so we cut a hole out of there. And then we have a disc underneath to say the disc it's on its way to being open, like that. So the servo just spins. So the horn, you imagine that's the horn of the servo, and it's attached to the shelf or the side of the box, and that will spin the shelf in place and it will spin it back out again. We need to think about, should they get it correct? The screen shows them they got it correct. The box opens, they grab their prize, and then the box closes again, because you want multiple people to have a go at this, right? I suppose you need to open it to put another prize in. And that's what the button is for. So you need to think about, where is the button going to go on the box? We also need the power supply for the Pi. So I'm thinking out the back here somewhere, and then the button and the screen out the front here. Another hole cut in the front of the box. And this is cutting probably quite thick acrylic, which we don't want to do with a laser cutter. Maybe we can mill it though. Depends on the thickness of the plastic. So we're going to look at a couple of boxes. But right now we can kind of get everything set up and working and go shopping to get these things before we have to worry about the box. So the voice box then, I found this hat. This is the Seed re-speaker board. It's got some I2C, some JST, and these are Grove connectors. So it's got loads of connectors, and the microphone are built in, and that's like your speaker output. So, and it's got a button on it, and some little tiny NeoPixel lights. So this looks perfect actually for what I need. I was looking at kind of these kind of screens. This is a screen from Pimoroni, the Display Hat Mini. It comes with buttons, an LED, RGB LED, and it's very small and compact, but, well, when it's on a Pi Zero, you can add it to the full Pi, but it doesn't give me any more. It does have, I think it does have a Grove, not a Grove connector, what's that called? Oh, the Adafruit one. Yeah, that connector. Stemma. Yeah, it has a Stemma connector on it, so you could add more things, but I think this is a full LCD screen. It's a bit overkill, so, and then like having the microphones and stuff, so this would just be the screen. So I'm not going for this screen. I'm just going for this little TFT screen here. And the servo is here. This is the same servo I used for my Baroque door project. And then we've got the option of all the buttons. So I'm going to show these to the linguistics guys, see what they think. This is like an arcade button mini. I think they'll love these, but they're a bit pricey. So here's some more simple buttons, the 20p one and this little square one. I think you can add labels to this one, which is quite cool. But since we only have one button, don't really need it. This is a very cool one as well. I think this is light up, maybe. Kind of looks like it should be. What was this? Oh, I think this is part of that. Then we have like a power switch, so that might go, I might put that on the back, so it's like on off switch, so we can add that to the power cable, chop up the power cable and add this in. We've got the SD card, we've got the Pi 3, and oh, very important, we've got these cables. So this is the Grove cable to male or female jumper wires. These are female jumper wires. I put all the shopping list on the Element 14 community, so you can download all of this and check out where I got everything. I'm going to need something else because this servo one, so the Grove ones have 4 connectors, and the servo only needs 3, which gives us 1 spare, which is great for the button, but I don't really want to break out a breakboard for the other, you know, the button needs two pins. So I don't want to add a breadboard to this setup. So what I might do is there's this hat, like I think it's called a hacker hat, and you can add it on here, and it separates out your pins into 2 sections. So that will give me access to a lot more pins, so I can add on the button without using an extra breadboard. While I wait for that board to arrive, I can start installing the re-speaker hat and get that working on the Pi 3. Now we're back in business. We're gonna check the audio settings. If we can spell Alt Mixer. Right, F6 is we select the sound card. So we can see that the Seed one is there. So let's press F5 just to view everything. So just looking at all the settings, making sure nothing's on mute basically. So, oh, the capture looks a bit low, but maybe that's okay. Don't need to worry about these ones. And escape. Right. This command helps us do a record. So it's saying record with this device. This is the hertz. This is the settings, T, 5 seconds, and as a WAV file. So we're going to try and record for 5 seconds. 1, 2, 3. Let's see if that will work. We're going to try and record for 5 seconds. 1, 2, 3. Hey, that worked. So the microphones aren't amazing. So yeah, there's a bit of crackling, but there'll be a bit of crackling in the recording of the kids' attempt. So that doesn't matter. We're happy. We're happy with a bit of crackling. We could try and tidy it up. Actually leave that to the linguistics people because that's their area of expertise. But the re-speaker is working. Let's get the servo and the screen up next. So to install the OLED, I'm using instructions from Raspberry Pi Spy. This is a great website. It's got loads of great tutorials for the Raspberry Pi. So I'm going to run that code on the 3D box. Hang on, we need to change our directory. Luma, examples, and try again. And look, it's a little 3D box. Let's try some other examples. Invaders? Invaders. Let's see what invaders does. Oh, look at the... Don't know what that was. Maybe I had my finger on the thing, but... Yay! It's a little animation of Space Invaders. I'm really interested now in what Jet Set Willy is. If anybody knows what that is, let me know in the comments. But I think I'm about to find out. Okay, it's a person walking away from another person and a bunny bouncing. Excellent, that makes perfect sense to me. But yep, that's the screen working, which is nice and easy. Next up, we're gonna add the servo. For the servo then, I think we need this GPIO0 library. I'm just gonna copy over some code. We know servos from other projects, so here's code to move it, pause, and then move it back again. There we go. That is working beautifully. We can ignore that warning. I can't remember if I stopped this in the code. It goes on forever. What did I do? Oh, I did it forever, yep. But that's the servo working. That's the screen working. We need to add our hacker hat to get the buttons on. But one last thing we actually need to do is install a library for comparing two voice files. So let's do that. So we've got a few libraries that we need to install. I'll put all these instructions on the Element 14 community. Next we need Pi Audio. We need the library VOX and NumPy. The next step is to download the model that we need. So this is the website, and we're going to go for just the VOX model with English speaker identification model. So this is it, VOX model speaker 0.4. So we need to download that and upload it to the Pi. Let's start by recording our password. Hello, my name is Lorraine, and my voice is my password. So that was 5 seconds. Let's just play that. Hello, my name is Lorraine, and my voice is my password. So the first time it runs, it downloads the model from the website. So the next time it runs, we shouldn't need to be connected to the internet, and it should all just work. Hello, my name is Lorraine, and my voice is my password. Oh, okay. So it gives you kind of a transcript of what I said. I could not remember what I was supposed to say. 0.48. So I'm halfway to my own voice. Let me see what I was supposed to say. Try that again. Hello, my name is Lorraine, and my voice is my password. Oh, it was pretty spot on. Okay, let's try that again. This time I won't download the library, so it should be a lot faster. My name is Lorraine, and my voice is my password. Hello, my name is Lorraine, and my voice is my password. Oh, I think I didn't get... Oh, I said the right words, but I think it said go, and I paused for too long. But I'm getting closer, 0.41. Come on. So I need to, when it says getting a temp signature. That's when I need to speak. Hello, my name is Lorraine and my voice is my password. 0.34, woo! So it'll be up to the linguistics people, so they can choose to tidy up the audio. Also, like that pause is going to kill a lot of people, I think. So maybe they could clip it until it has a sound. And also they decide, you know, maybe 3 is fine, maybe 3 is close enough. So they decide on that threshold. But I'm really happy that worked. So the first thing we're going to do is attach the pie. I'm going to draw some holes here and drill them in. Because we don't want the pie to slide around as the kids are kind of like shaking the box and looking into it. Then I'm going to laser cut an acrylic wall to go kind of here, maybe 3/4 along. And I'm going to 3D print some mounts, put them here and then drill them. At the front of the box, kind of here, is going to be a hole, about like a rectangle, and we're going to have the servo mounted just below it, and it's going to have like a hook, like literally a hook that comes through in lock position, so you can't lift the lid when it's locked. And then when they guess the password correctly, it's going to spin out using the servo, and then you'll be able to take the lid off. I'm going to create a hinge here so that only this bit lifts up, like where the wall is, so you can't access the pie at all. So we're going to screw down these sides of the box so you can't lift this bit of the box. Then we need the screen here and possibly a button. I need to check with linguistics how they want it to all work. My name is Lorraine and my voice is my password. My name is Lorraine and my voice is my password. Okay, so then we lock the box. We'd normally screw this all together. And you can see it's locked there and we can't get the suite. My name is Lorraine and my voice is my password. My name is Lorraine and my voice is my password. Yes. 4. I win! So it opened. So now I can open this and I get the chocolate. And it'll be maybe a bit more delay on that because now I can't close the box because the thing's in the way. You ready?
Yeah.
So this is your screen here. It says ready. That's your button.
Mm-hmm.
My name is Lorraine and my voice is my password.
My name is Lorraine and my voice is my password.
Calculating. It was a bit fast.
Yeah.
You have to get below 0.5.
Okay.
No! Do you want to try again?
Yeah.
Okay.
My name is Lorraine and my voice is my password.
I don't sound like that.
I know. 0.7 more.
What was worse? How was that worse? Right, I'm going to try and break it. I'll show you. I get the chocolate though.
Wait, what?
If I win, right?
Hang on. This is rigged. It's your code and your voice.
Shh, wait. My name is Lorraine and my voice is my password. My name is Lorraine and my voice is my password. Calculating.
Damn it.
0.4! Yes! Pretty awesome, huh? How would you break it?
With a hammer.
How would you break the password?
With a ventriloquist.
A ventriloquist?
Yeah.
I don't think they can mimic. Can they mimic voice?
I'm pretty sure they can.
Okay.
Or just a recording of you. I'll just record it. Record what you said and then did that.
Yeah, that could work. Do you want to try that?
Yeah.
My name is Lorraine and my voice is my password.
Did we do it?
Yeah.
We broke the system. You're no sweet though. Well done, you little hacker.
I broke it. I broke it.
Good job.
I'm just that good.
Here you go. Well done. Yeah, you can have it. So that was the VOX voice box. I am getting better at saying it. I'm really happy with this project. I don't like speakers. And it took a lot of kind of debugging to get that working, to get that code working, but I'm glad it's done because I can't wait to build 4 more of these for the linguistics department. And they're going to try it out with kids on linguistic outreach days. What's going to be really funny is kids working out the techniques to try and break the password. Because I listen to the audio and will they realise that they can't have any background noise, so they have to be quiet. So kids will be like, shut up, shut up, shut up, shut up. And then we could get some like really good accents and see if they can try and duplicate someone's accent. It's going to be a lot of fun to watch. I hope you enjoyed this video, and if you have any questions, come to the Element 14 community and I'll be there to answer them. Until next time.